All right, today, section 1.11, we're going to look at formulae and literal equations. And yes, formulae is the proper plural of formula, although most people today say formulas, and formulas is accepted. And in your book, it even says formulas, but formulae is actually correct. All right, so typically, when I cover this section, I'll ask students, tell me a formula that you know. And the first one they almost always give me is y equals mx plus b. And they'll say that's the slope formula. And I will say, no, that is not the slope formula. Although that formula does have slope in it. M is the slope. This is actually slope intercept form of a line. M is the slope of the line, and 0 comma b is the y-intercept. A very important formula, one that we will definitely talk about in the future. But the slope formula, if you want that one, that's m equals y2 minus y1 over x2 minus x1. And in this formula, notice that these are subscripts. They're low. They should not be written up here. If they're written up here, then they're exponents. This is simply saying the second y value minus the first y value, and then the second x value minus the first x value. And this subscript notation is a very common thing. Let me give you another very famous formula that you might see in the future. 1 over r equals 1 over r1 plus 1 over r2. This is a very famous formula from electricity, where R is the total resistance in a circuit, and 1 over the total resistance is 1 over the first resistance plus 1 over the second resistance. So notice again, the subscript notation that we use is simply to indicate this is the first thing, this is the second thing, but they're kind of the same. These are both resistance. This is just resistance 1, resistance 2. So depending on what program you're in, you might take an electricity class, and when you do, I'm sure you'll see that formula. Okay, other formulas that you know that we've already talked about in this class. Area is length times width. We've talked about that one. Area is 1/2 base height. Area of a triangle. Area is pi r squared. Area of a circle. Let's see, we did trapezoids too, didn't we? Area was 1/2 the height times base 1 plus base 2. There's a whole bunch of famous formulas you know. Oh, here's another one that you might know. I'm going to write it back up here because it goes up with lines. Y minus y1 is m times x minus x1. If you haven't seen that one before, don't worry. You will see it again in the future. This is another equation of a line. This one's called point slope. M is still the slope, and x1, y1 is any point on the line. That's why it's called point slope. There are, millions and millions of formulas out there. Another one students will always give me is a squared plus b squared equals c squared. That's our Pythagorean theorem. Works in a right triangle. Another very famous one that students will sometimes say is E equals mc squared. That's Einstein's formula. Energy is mass times the speed of light squared. Okay, so what we're going to do in this section is we're going to rearrange formulas. Let's go back to this one here. Y equals mx plus b. Right now, we would say this equation is solved for y. Meaning, there's y on this side all by itself, and there's other letters on the other side, but none of them are the letter y. So when we say solve for y, we mean we have y on one side and no y's over on the other side. Now, while this is a very useful form of this equation, sometimes in certain situations, it's helpful to have this equation solved for x, meaning we want the x all by itself and no x's on the other side. And so that's what most of this section is going to be about. You'll be given y equals mx plus b, and the directions will be solve for x. Now, this I find bothers students a lot when there's all these letters in it. So I'm going to go off and do an example first and show you that it really doesn't matter that there's a bunch of letters. It really is the same process as when you have a bunch of numbers. So if I gave you this equation, 5 equals 2x plus, say, 9. And I asked you to solve for x. Students wouldn't flinch at that at all. You would tell me subtract the 9 on both sides. Minus 4 equals 2x. And then you would say divide both sides by 2. So minus 2 equals x. This equation back up here, solving for x, is really the exact same thing. We're trying to get this x all by itself. X is connected by a multiply, and it's also connected by an add, just like it was here. Connected by a multiply, connected by an add. The first thing we do is we get rid of the add. We subtract the 9 on both sides. Same thing happens here. We're connected by a multiply and an add. We get rid of the add. We do minus b on both sides. Now, here's where the difference really comes. Over here, the best I can do is write y minus b equals mx. The big difference was when I subtracted 9 on both sides, these are, both numbers. I can combine them and call them -4. Here I can't. But it's the same thing. We would subtract 9 on both sides just like we would subtract b on both sides. Then the x is connected to something by a multiply, just like it was here, so we did a divide. So we do a divide. So here's our answer. X equals y minus b over m. All right, so let's take a bunch of these other equations and try to rearrange them too. Some will be easier than others, as you'll see. Let's say I gave you a equals 1/2 bh, and I wanted you to solve for b. Okay, so the other day when we talked about solving equations, we talked about what to do when equations have fractions. My method when equations have fractions is to get rid of fractions. So what I would do first is I would get rid of this 1/2. To get rid of this 1/2, I wish I had a different color. Here we go. I'm going to multiply both sides by 2. So that gives me 2a equals 2 times 1/2 is 1 bh. And then I notice I'm trying to get this b all by itself. It's connected by a multiply. To get rid of a multiply, I do a divide. So my answer is b is 2a over h. Okay? Hope that makes sense. All right, let's try a slightly harder one. A equals 1/2 h times b1 plus b2. And this time I want to solve for b2. All right, so we have some issues here. This b2 is trapped inside of these parentheses. So we're going to have to figure out how to get rid of those parentheses. And there's a couple different ways you can handle it. And I'll do this problem 2 different ways and show you how, depending on how you do it, you get 2 different looking answers. But first, just like last time, I see that this equation has a fraction. So my first step in either case would be I'm going to get rid of the fraction. So again, I'm going to multiply both sides by 2. I get 2a equals h times b1 plus b2. All right, so we're still trying to get this b2 all by itself. It's trapped inside these parentheses. We have to get rid of the parentheses. There are two ways we can get rid of the parentheses. The first, what most students would say, is let's distribute. And we'll do that. And then we'll do this problem again, and I'll show you a slightly different way. 2a is hb1 plus hb2. All right, so again, I'm trying to get this b2 all by itself. I notice that this b2 is connected by a multiply right there, and it's also connected by an add. So when things are connected by a multiply and connected by an add, we do the adding and subtracting first. So we would do minus hb1 on both sides. 2a minus hb1 is hb2. And now we have the b2 almost all by itself. It's simply connected by a multiply. So to get rid of that multiply, we do a divide. And our answer would be b2 is 2a minus hb1 all over h. All right, now I'm going to take this exact same problem and I'm going to do it again. But I'm going to do it in a slightly different way to show you a slightly different way that you could get rid of those parentheses. So I'm going to start with a equals 1/2 h times b1 plus b2. The first step is exactly the same. Multiply both sides by 2 to get rid of the fraction. 2a is h times b1 plus b2. Now, last time we distributed. A different way to get rid of this set of parentheses would be to take this equation and divide both sides by h. Get rid of that multiplication. That would also get rid of the parentheses because we don't have the multiplication anymore. We don't need the parentheses. 2a over h is b1 plus b2. And now notice that the b2 is almost all by itself. The only thing we have to do is get rid of this add. To get rid of an add, we do a subtract. So we subtract a b1 on both sides. And our answer would be b2 is 2a over h minus b1. And notice that b1 is not part of this fraction. Oops, can't see that. Notice this b1 is not part of that fraction because in order to combine these, we would have to have a common denominator. So notice something interesting here, that you can solve different ways and you get different looking answers. So if you're doing your homework and you're checking against somebody else and you have slightly different looking answers, it doesn't mean one of you is right and one of you is wrong. It might mean that you did the problem other ways. All right, so I'm going to pause here because the software I'm using only allows me to record videos up to 15 minutes, and this one's almost 14 minutes long. So I'm going to pause, and then I'll start another video, and we'll do some more problems.